Hello everyone. Today we will be looking at GATE Chemical Engineering question number 56 from GATE 2022. An equimolar binary mixture is to be separated in a simple tray distillation column. The feed rate is 50 kmol per minute. The mole fractions of the more volatile component in the top and bottom products are 0.990 and 0.01 respectively. The feed as well as the reflex stream are saturated liquids. On application of the McCabe-Thiele method, the operating line for the stripping section is obtained as y equal to 1.5x minus 0.005, where y and x are the mole fractions of the more volatile component in the vapor and liquid phases respectively. The reflex ratio is dash rounded off to 2 decimal places. So this is from distillation part of mass transfer, and the NPTEL lecture series for the concepts of distillation can be obtained in lecture 1, week 9, Introduction to Distillation in Mass Transfer Operations 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So let's look into some brief things about the distillation column. So we have a distillation column with F as the feed, with XF as the small fraction of the more volatile component in the feed. Then the top part we have the condenser unit with a condenser giving us the distillate D, and the bottom part is the reboiler unit which gives us our residue W. So the bottom half of the distillation column is called as stripping section, which is from the tray below the feed, and the top half is called as the enriching section. So let's write down the data that we have from the question so far. We have F, which is the feed rate, as 50 kilomole per minute, and the feed is equimolar binary mixture. That means the composition of the more volatile component and less volatile component both are equal, and XF is equal to 0.5. Then we have XD equal to 0.9, which is nothing but the mole fraction of the more volatile component in the distillate. Then we have XW equal to 0.01, which is the mole fraction of the more volatile component in the residue. Another data they have given is that feed is a saturated liquid. That means another entity Q is introduced as 1, and Q is nothing but the fraction of liquid available in the feed. So writing the material and component balance for the whole distillation column, so we have a distillation column, say our feed F, then the distillate D and the residue W with their corresponding compositions as XF, XD and XW. So the material balance will give us F is equal to D plus W. So we have F as 50, which is given in the question. So 50 is equal to D plus W. Now writing the component balance for the more volatile component, we can write FXF is equal to DXD plus WXW. So this is equation 1, and substituting the values here, we will get our equation 2 as 25 is equal to 0.9D plus 0.01 XW, which is our equation 2. So solving these two equations, we can get the values for distillate and residue D equal to 27.5 kilomole per minute, and W is equal to 22.47 kilomole per minute. Now let's go to the stripping section of the distillation column. They have given us the equation for stripping section as y equal to 1.5x minus 0.005. The general equation for the stripping section, we can write it as y equal to rv plus 1 by rv into x minus xw by rv. Now rv is nothing but the boil up ratio. So we can see the reboiler part. So we have residue W, then we have V bar, which is the vapor being recycled into the distillation column. So RV is nothing but the ratio of V bar by W, which is the ratio of the vapor going back into the distillation column divided by the residue. So comparing these two equations, we can say that RV plus 1 by RV is equal to 1.5. And solving this equation, we can get the value for RV as 2. So RV, as I said, is V bar by W is equal to 2. And we have the value for W, which is the residue, which we found from the last section. So then we can find the value of V bar as 2W, which is nothing but 44.94 kilomole per minute. Now, feed is a saturated liquid as given in the question. So Q is equal to 1. So if we take the balance of the feed tray, we can get F as the feed. Then there are incomings and outgoings in the form of L bar, and V bar. Writing the balance, we can write F is equal to L plus V bar. F plus L plus V bar is equal to L plus V. And since Q is equal to 1, we can say V equal to V bar. Now let's see how this comes into B. So we can write L bar is equal to L plus QF. So L bar is the liquid which is going below the feed tray. So this L bar is equal to L, which is incoming into the feed tray, plus QF, which is nothing but the fraction of liquid available in the feed. Similarly, we can write V bar is equal to V minus 1 minus Q into F. So since Q is equal to 1, 1 minus Q will be 0. So then this equation will become V bar is equal to V. So V bar is equal to V is equal to 44.94 kilomole per minute. So the reflex ratio is equal to L by D. We have the value for D, but we need to find L. For that, we will be writing a condenser material balance. So let's take this our condenser. We have the outgoing D, then the recycled part L, and the incoming V. So the condenser balance, we can write it as V equal to L plus D. We have V as 44.94 kilomole per minute and D distillate as 27.5. So we can have D L. So we can have L equal to V minus D, which is 17.44 kilomole per minute. So reflex ratio is equal to R, which is equal to L by D, which is 17.44 by 27.5. And we'll be getting our answer approximately as 0.63. So the range can vary from 0.61 to 65 for the right answer.